Equal cost multipath or ECMP is commonly used to achieve load sharing across multiple paths, right? Load sharing, not load balancing. Both are different. Load balancing and load sharing, they both are not same, because in load balancing, traffic is distributed in the ratio of like metric or maybe cost of different paths, whereas load sharing means 1:1 ratio. Traffic is divided equally across different paths, right? Let's first understand ECMP in detail, and then I will practically demonstrate, I will practically show you how we can achieve load balancing. And it's very strange, right? How we can achieve load balancing in static routing. It looks next to impossible, right? Configuring or achieving load balancing in static routing, it looks very difficult, right? And of course there is no straightforward way to achieve load balancing in static routing, but yes, like we can use some tactic, we can use some trick to like achieve load balancing in static routing, right? But let's first understand ECMP, and then I will show you practically how we can like achieve load balancing in static routing. But first thing first, so first let's understand ECMP in detail, and then I'll talk about static, dynamic routing, load balancing, load setting, all that stuff. So ECMP, equal cost multipath, I hope is very easy to understand. If there are multiple or different paths to reach the destination, destination here is 40,000. So if there are different paths, like one via R2, then R4, and another path via R3 and then R4, right? So of course there are two different routes, two different path, maybe using static or dynamic routing. So if AD value and metric both are same, then what happens? ECMP, equal cost multipath, right? Traffic is distributed in equal ratio, that is 1:1 in case of two different paths. Okay, so first of course criteria is AD value. If there is tie, then metric. Metric could be of course cost or hop count, depends like whether like we are using OSPF, RIP, ERP, static routing. So that's all about ECMP, right? Equal cost multipath. And now if there are two different routes to reach the same destination, as I said before, but if one of the link has like 100 Mbps bandwidth and the link 50 Mbps bandwidth, right? Even in case if we want to achieve even ECMP or load sharing, let's say we have configured OSPF protocol, open shortest path first. Then in OSPF what happens? If both links like running same protocols, of course OSPF AD value same, then next criteria would be here metric. What is metric in OSPF? Cost. Cost is computed from the bandwidth. So of course 100 Mbps means lower cost, lower than this 50 Mbps, then like this path would become the best path and traffic will be routed via 100 Mbps. In case if we want to do ECMP, equal cost multipath, then of course we can do some like tweak here. For example, we can adjust, we can manually configure cost, OSPF cost, and in case if both links have equal cost, maybe 10 here and 10 here, equal cost, right? Then what would happen? ECMP, equal cost multipath. Traffic is now distributed equally across different paths. So is it load balancing? No. True load balancing is supported only by which protocol? Do you have any idea? OSPF? No. RIP? No. ERP? Yes. ERP is the only protocol that provides true load balancing. because EIP provides both equal cost multipath and unequal metric path load balancing also. Unequal metric path load balancing also means traffic is distributed in the ratio of their composite matrix. Make sense? Good so far? Now, what about static routing? Can we achieve load sharing and load balancing both in static routing? So, load sharing is very straightforward, right? I hope you all know like how to do load sharing, not balancing, in static routing, and how we can do that. So in case if there are two routers, R1, R2, interface IP 1.1.1, 1.1.2, 2.2.2.1 and 2.2.2.2, and network here is 20.0.0/8. So what we can do here, we can create two static route from R1, right? IP route 20.0.0.0 mask, next hop IP, then another route IP route, same destination, same subnet mask, and this time next hop IP different, and there is no AD value here. So static route or static routing means default AD value 1, default AD value, administrative distance value is 1. So if both routes have same AD value, and in static routing there is no concept of metric, right? So if both have same AD value, there is tie, and tie means eventually like ECMP, equal cost multipath. Both routes will be installed in the routing table, and R1 will use both the routes to route traffic to 20 network, this network. Good so far? I hope you understand this concept, and I'm 100% sure like you all know that how to do equal cost multipath or load sharing, right? Now here is a twist, and twist is, let us assume first link is of 100 Mbps and another 50 Mbps. So load sharing means what? Distributing traffic equally, right, across both the paths. But as a result, 50 Mbps link will be overutilized, 100 Mbps link will be underutilized. Understood? So is this load balancing? Of course not. It's a load sharing. Load is shared across two different paths but not balanced, right? But let us assume we want to achieve true load balancing in static routing, means distributing traffic not equally, unequal cost path in ratio of 2:1. 2 packets from here, then 1 packet from here, again 2 packets from this link, 1 packet from here, in the ratio of 2:1. But is it possible in static routing? Generally no, not possible, because here like there is no concept of cost, no like metric, only AD value. And if we change the AD value, for example here AD value is 1 and AD value is 2, then what happens? Route with the lowest AD value is installed in the routing table, becomes primary route. In case primary route goes down, becomes unavailable, then backup route with the higher AD value will be installed in the routing table, right? That's what like primary and backup route configuration in static routing. So even if we try to play with the AD value, so still we cannot achieve result, right? Because objective is to configure load balancing, means unequal cost path in static routing. Really looks very difficult, almost next to impossible, right? but is there any trick, any technique, a tactic that can be used in static routing? So now let me practically show you how we can accomplish the task in static routing. So as I said before, EIGRP is the only protocol that provides true load balancing. Otherwise, other protocols, they provide load sharing, that is XCMP, equal cost multipath. Of course, if cost is not equal, metric is not equal, then we can make that cost or metric equal with maybe manipulating bandwidth, delay, other attribute, or maybe state away changing metric. Like in EIGRP, we have offset list. In RIP also, we do have like advanced technique like to play with the metric, that is offset list. So even in RIP also we can do that. So that is not impossible. For example, if here, like, let me pick the scalar R1, there is one hop and another path has two hop. Still I want to do load sharing. Protocol is RIP. We know, like in RIP what happens, hop count is the metric used in RIP protocol. Hop count means number of hops. So obviously, like here, like there is hop count total 2 and hop count 3 to reach here 50 network maybe, right? So is it possible to do load sharing even in RIP protocol with this scenario? No. But what if we manipulate metric of RIP, or somehow if we configure that both routes or both paths have equal number of hop count, right? Maybe 3 hop count here, 3 hop count here. Is that possible? Yes, we do have like offset list. So we can use offset list to manipulate RIP metric, EIGRP metric. In OSPF, like state away, we can change the cost, IP OSPF cost command per interface basis, right? But mainly I want to focus static routing, so I don't want to get into like RIP OSPF and the protocols. So in static routing, since like there is no metric, there is no cost, there is no hop count, only AD value, so really is like very tedious job to do to achieve load balancing. So let me show you a topology like wherein like we are going to configure load balancing in static routing. Alright, so if you look at the topology here, then there are two routers, right? And from R1, let's say we want to do unequal cost load balancing, not load sharing, right? To route traffic for this network 172.16.1.0, and you can see here like there are two different paths to reach the destination. One is like F0/1 interface and another F0/0 interface, right? There are two different types, but 100 MPS and 200 MPS. So simply if we create a static route with the same AD value, right, two routes with the same AD value, then means like 1:1 ratio traffic is distributed equally across both the links. But 100 MPS, 200 MPS, 100 MPS, right? So we don't want like one of the links should be overutilized, another link should be underutilized. So what exactly we want to accomplish here? 2:1 ratio. 2:1 ratio means like 2 packets from here, then 1 here. 2:1 ratio, right? From here to here. How we can do that? So let me open console of first R1, and I hope you can see diagram also. Yes, okay. R1. So both routers are not configured, so let me quickly turn off logging console and set the host name. Host name is R1, F1/0 interface, IP address 10.1.1.1 255.255.255/0, no shutdown, and the F0 1 interface IP address 1.1.1 255.255.255.0, no shutdown, right? F0/0 interface IP address 2.2.2.1 255.255.255.0, right? IP address 3.3.3.1 255.255.255.0 secondary. What I did now, and that's what the trick is, right? So IP address assigned here 1.1.1, and of course I will assign 1.1.2, and to this interface I've assigned two IPs, secondary IP, right? Same I will do here, right? And routing wise, what I will do, I will create 3 different routes or paths to reach the destination. One path with next hop 1.1.2, another route with next hop, and another path with the next hop, this, and same AD value, of course. So as a result, what would happen? All 3 routes will be installed in the routing table here. So if we will check the routing table, show IP route, then we will see 3 different routes with 3 different links or paths, right? So R1 will assume as if there are 3 different links, right? In reality, there are only 2 links, not 3. So traffic is still distributed 1:1:1. But you understand, like, in reality there are only 2 links. So even if next hop 222 is used or 333, means both packets will be routed via this link, 200 Mbps link, and 100 Mbps if there is one link. Means traffic is distributed equally, like 1:1:1, but secondary IP is assigned to the interface, like a link with the 200 Mbps. So this way we can achieve 2:1 ratio load balancing, right? So far what I have done here on R1, let me show you one more time. So if you check the routing table for now, so 1.1.1.0 is directly connected, and 10.1.1, and where is 3.3.1 and 2.2.1, right? While like not showing up here in the routing table, if you look at the routing table, then we can see here there is only 1.1.0 and 10.1.1.0 because interface is administratively down. I believe we forget to run no shutdown command, that's the reason, right? So no worries, like F0/0, bring up the interface with no shutdown command, check routing table one more time, and here we go. So 10.1.1 is the LAN interface, forget it, and then it looks like there are total 3 interfaces, external interfaces, WAN ports, but in reality only there are 2 ports. Exactly in the same way I'm going to configure R2 also. Once interfaces are up, then I will show you routing part. Host name R2, no logging console, just to turn off. F0, which one? F1/0 is the LAN interface. F1/0 IP address 172.16.1.1 255.255.255.0, no shutdown. And then here F0/1 interface, 0/1 interface is this 0/1 IP address 1.1.2/255.255.255.0, and don't forget to bring up the interface. F0/0 first IP 2.2.2 mask/24, then another IP 3.3.3.2 255.255.255.0, bring up the interface with no shutdown command and check the routing table. Directly connected routes will be shown here. So still I cannot see interface 0/0. Oops, so I believe we forgot to yes, we forgot to mention here secondary IP. So what happened, IP address is replaced. So in IP version 4, if you do not specify secondary IP, so what happened, like the IP address assigned previously gone like from here and overwritten. In IP version 6 there is no problem, right? If you assign another IP address, so both IP address would be there. But in IP version 4, yes, like secondary command is required. So basically we forward to run secondary, and that's why you don't see like another IP address assigned here. No problem. Interface F0/0 IP address 2.2.2.2 and secondary, right? This way you can assign multiple IPs, not only two, even more than two IPs can be assigned to an interface. Show IP int brief, interfaces are up, show IP route, and now here we can see total 4 routes here, right? So far what we have done, so let me write down. So I've assigned 1.1.1 IP address here, okay, and 1.1.1.2 IP address to another end, and here like 2 IPs, 2.2.1 and 3.3.3.1, right? Secondary IP basically, okay, 2 IPs, and same here like on the right hand side is this interface, right? 2 and 2. So basically there are 2 interfaces only, but assumption here is like there are total 3 interfaces, right? So even traffic sent to 2.2.2 or 3.3.2 will be landed to this like interface will be used here. So it's 1:1:1, but eventually like we would receive like 1:2 ratio. So 1 traffic via this link, then 2 from here. So what about routing then? It's simple. If I have to do static routing now, so destination network 1.0 255.255.255.0 1.1.2, then another 2.2.2.2, another 3.3.3.2. Make sense? I hope you understand the trick here and see here. So basically total there are 3 different paths, right? 1.1.1 is, yes, physical interface is different, but what about these 2 routes? Same physical interface, but 3 routes, secondary IP, and similarly you can configure R2 also. I hope you understand how we can achieve load balancing in static routing. Tricky one, right? Otherwise there is no way to achieve load balancing in static routing. Even in OSPF, reprodual also not possible without any trick or tactics, or maybe doing some source based routing or policy based routing or something, right? Because EIGRP is the only protocol that provides equal cost and as well as unequal cost, or unequal metric rather I would say, because in EIGRP composite metric is used. So EIGRP is the only protocol that provides true load balancing, right? Because traffic share count is computed, or calculated based on composite metric. So in EIGRP, load sharing, load balancing both are supported, whereas in static routing or other protocols only load sharing, right? For load sharing, yes, we can do like AD value manipulation, cost manipulation, metric manipulation, right? So I hope you understand difference between load balancing, load sharing, and how we can configure load balancing in static routing.